My name is Ashish Agarwal, and I'll be delivering this lecture to you. So before commencing the session, just a quick round of update regarding my YouTube channel, which is youtube.com/Ashish Agarwal_GG. So if you haven't visited the channel, I would request you to do visit the channel and do like, share, and subscribe the channel. The channel is dedicated to Oracle Goldengate related videos. Thank you. So in today's session, we are going to discuss regarding difference between lag at checkpoint and time since checkpoint. If you have noticed, one thing which I told you in the previous sessions was, and during the troubleshooting part as well, should always be less than 10 seconds. This is the thing which I told you. So what do we mean by this should be less than 10 seconds? And what is the need for it? So let us discuss about that. So first of all, before we proceed with that, to understand there are what are the different process status. So there can be, like, you see the manager process is running, extract process is running, or replicate process would be running. So what are the different status over here for each process? So different status of each process includes either it would be running, or stopped, or starting, or abandoned. So abandoned means it is abnormal end. So the process is stopped after encountering some abnormal condition, due to which it has gone into abnormal mode. It has gone into abandoned. Okay. Starting means when you start the process initially, it first goes into starting mode. So during starting mode, it initializes itself. It reads the parameter file. And after that, it moves into the running. Stop means graceful stop. So most of the cases, when you do graceful stop, then the process stops. And last is running. So running means the process is running. But there is a catch to it. The time since checkpoint should be less than time since checkpoint is less than 10 seconds. So until time since checkpoint for a process is not less than 10 seconds, you cannot confirm that the process is running. From there, the process can go into abandoned or stop mode as well. Okay. So these are the four process statuses which you can find: running, stopped, starting, or abandoned. So abandoned means abnormal end. So when the process is in abnormal end mode, like you see process is abandoned, or even when you start the process but still it shows you in the stopped mode, so it means that how can you find what is the issue? You need to view the report file of it. So you can do view report process name to identify the reason for this. Okay. So now once you have identified these statuses, now one quick question to you. This is a question for everyone. Suppose your gold, so these manager, extract, or replicate or data pump process, these are called as Golden Gate processes. So we call them as Golden Gate processes basically. So extract is a Golden Gate process, replicate is a Golden Gate process, data pump is a Golden Gate process, manager is a Golden Gate process. So all these collectively are known as Golden Gate processes. Okay. So now suppose, just this is a question to you. Now suppose until Friday 10 p.m. are running fine. Now, this is the time you left off. Now, at 10:00 p.m., when no one was there, and this was not the critical environment, and no one was there, 10 p.m. on Friday, 10 p.m. itself. So I should, just to remove the confusion, I should say 09:59 p.m. So until 09:59 p.m., the Golden Gate processes are running fine. At 10 p.m. on Friday, the OGG process goes down due to some reason. The Oracle Goldengate process goes down at 10 p.m. on Friday. Now, there was no one to look after it, no one looked into the issue. So it didn't come up on Friday and on weekend. On Monday, 9 a.m., you restarted the process by resolving it. So on Monday, 9 a.m., the process is running. So my question to you is, from what time the Golden Gate process will start capturing the data from? Will it start capturing the data from Friday 10 p.m. or Monday 9 a.m.? And what is the reason for the same?
Friday 10 p.m.
Friday 10 p.m.
But we are starting it on Monday 9 a.m., right?
Yeah, but still we have all the logs recorded, all the
Lag
changes,
will
right?
still be there.
There,
checkpoint.
there will be a checkpoint from where it will start again.
Okay.
It's based on change data capture. So whatever changes has happened would be tracked down, and then as per the change data capture, the sync would proceed.
Right. Okay. So the thing here is, see, if it starts from Monday 9 a.m., you're starting it from Monday 9 a.m., but we'll start it, but it has to ensure that we see Golden Gate is a product which ensures zero data loss in your environment. Right. So suppose if you start it at Monday 9 a.m. So if it start capturing the data from Monday 9 a.m., but the application wasn't down on weekend, so what will happen to that data from Friday 10 p.m. to Monday 9 a.m.? You will lose that data. And that is not the purpose of Oracle Goldengate. So even though you are starting from Monday 9 a.m., it should start capturing the data from Friday 10 p.m. So basically, when it was stopped at, it should start capturing the data from the very same time. Okay. So how does Golden Gate know? So when you're starting the Golden Gate process on Monday 9 a.m., how does Golden Gate know that it has to start capturing the data from Friday 10 p.m.? Is there something related to Oracle Golden Gate? Yes. The answer to this question is yes. So in Golden Gate, each Golden Gate process, whether it is EXCINT, DPINT, or REPINT, which you have captured, each process in Oracle Golden Gate has a checkpoint file associated to it. So you see, you have got dir chk directory, right? So dir chk directory has a checkpoint file associated to each Golden Gate process. So this is very critical directory. So if you do dir chk, you can find checkpoint directory related to dpint and excint. So these checkpoint files are very critical files. So when the process is started, there are two things which are read. First is the parameter file and second is the checkpoint file. So these two files are read during the startup. So this checkpoint file is updated regularly every 10 seconds. So in this checkpoint file, it writes down what it has read until what time the data has been returned to the trail file or read, depending on the process type for which this checkpoint file is created for. So this checkpoint file has all the information related to the Golden Gate processes. So basically, so suppose if I say, for example, stop dpint. So what will happen now is your checkpoint file will stop updating the checkpoint file. So there will be no more updation of the checkpoint file in dir.chk. So basically what will happen? The checkpoint file will have the information that it has read the data until current time 9:50 p.m. And when Tuesday 9:50 p.m. as per or I should say server time. Sorry. So the server time is this. So now because we have started Golden Gate data pump process right now, so the checkpoint started after 10 days, 20 days, 30 days, 1 year, 2 years. It will have the same information available in the checkpoint file that am. So when you restart the process, it starts process startup. So see one thing. I'll stop, say for example, data pump. It is already stopped. So what the data pump time since checkpoint is 1 minute 16 seconds. So that means that the process was stopped 1 minute 16 minutes before, 1 minute 16 seconds before. The last time the checkpoint file associated to the process was last 76 seconds before, as per this 60 plus 16, 76. Right. So now when you stop the process, the checkpoint file is no longer updated. So even if you go to dirc, dpint.cpe was last updated at this. Until you restart the process, the checkpoint file will not be updated. So now when you restart the Golden Gate process, this dpint, so it will read the checkpoint file associated to the process. It will process the data based on the available in the checkpoint file, like until what point it has read the data from the source and until what point it has returned the data to the target. And then when from that particular point onwards, it will start processing the data from, ensuring there is zero data loss. So these checkpoint files of the process ensures there is zero data loss. Now, time since checkpoint is the last time when the checkpoint file associated to the process was last updated. That is called as time since checkpoint. So by default, each process updates the checkpoint file every 10 seconds. So every 10 seconds, the checkpoint file is updated by default. Okay. But suppose if there are long running transactions in the database, or if there are network issues, or if there is database slowness, then you may find, or if there are any other performance related issues, then you may find this time since checkpoint is not getting updated frequently. It may take more than 10 seconds. But as a general thumb rule, by default, each process updates its own checkpoint file every 10 seconds. Okay, so every 10 seconds, the checkpoint file is updated. So now you see this time since checkpoint is 9 seconds. So it means that the checkpoint file associated the process was last updated 9 seconds before. So when you so the whole purpose of these checkpoint files is to ensure the recovery is proper. If the checkpoint files are lost, these checkpoint files are very critical. Let me show you. I'll exit from GGSCI. I'll go to DIR-CHK. What I'll do, I'll move dpint.cpe to dpint.cpe underscore backup, for example. Now go to GGSCI, do info all. See, you cannot find data pump right now because the process here, our own directory is not there, or the checkpoint file is not there for any process. You won't find it over here. Okay, so these checkpoint files are very critical files. So let me again rename DIR-CHK mvdpint to .cp. Now if you go to, now again I have moved it to the proper name. Now if you go to GGSCI and do info all, you can find now your dpints. So these checkpoint files are really very critical files. If you lose them, you risk of losing the data. Okay, now see, the time since checkpoint is 5 minutes 21 seconds. So it means that the checkpoint file associated to the process was last updated 5 minutes 21 seconds before. So when you restart the process, it will the data pump process, it will read the checkpoint file associated to the dpint process, and it will start from the same point where it was stopped at. So again, I repeat, the whole purpose is to ensure that recovery is proper. There is zero data loss in Oracle Golden Gate environment. So one thing we always say is Golden Gate ensures zero data loss in its own environment. Which feature allows it to do that is this checkpoint in its own environment. So time since checkpoint means the time elapsed since last time the checkpoint file associated to the process was last updated. Lag at checkpoint means is lag encountered when the checkpoint file was getting updated. So lag at checkpoint means is lag encountered in the process when the checkpoint file associated to the process was updated. So say for example, every 10 seconds, the checkpoint file is getting updated. So whatever the lag of Oracle Goldengate process at that particular time is, it will tell you that particular lag. So say for example, the lag at that particular time is 3 seconds. So it will show you 3 seconds lag. If the lag at that particular time is 0.0000, it means it was in milliseconds. The lag was in milliseconds. Okay. So I also have a blog associated to it. The difference between time since checkpoint and lag at checkpoint. You can Google out as well. Uh, Ashish Agarwal, difference between time since checkpoint and lag at checkpoint. So you will get the first link, click on it. So you can find this blog. So in Oracle Goldengate, each process has its own checkpoint file. So when you do info all, output has its own checkpoint file. Similarly, dpint has its own checkpoint file. So the checkpoint files in classic architecture resides inside Goldengate home / dir chk directory. Okay. Checkpoint allows Oracle Goldengate to restart its process, ensuring zero data loss and data integrity. Consider the GG process was stopped on Friday 10 p.m. and due to weekend, no one looked into it. And they continued to be in stopped abandoned mode whole weekend. On Monday morning, they were restarted upon fixing the issue at 9 a.m. The question is, from what point it will start for processing the transactions upon restart? From 10 p.m. Friday when it was actually stopped, or 9 a.m. Monday when you restarted? What do you think? If it restarts from Monday 9 a.m., then there will be data loss. And if it restarts from 10 p.m. Friday, where will it get that information from? So as we mentioned, Goldengate ensures zero data loss. For that to happen, the process should start from 10 p.m. Friday. So this happens using Oracle Goldengate checkpoint. Each process in Goldengate has its own checkpoint files which gets updated by default every 10 seconds. So when the extract process will restart on Monday 9 a.m., it will refer to the checkpoint file present in dir chk directory, and based on information available or present, it will continue to process transactions upon restart. So when the process was stopped abandoned, the checkpoint file was last updated on Friday 10 p.m. Hence, process will start referring to the checkpoint file. Checkpointing in Oracle Goldengate will ensure data integrity. So the time since the checkpoint file associated to the process was last updated. So whatever the time has elapsed since the checkpoint file was updated, it is called as time since checkpoint. By default, the checkpoint file of each process gets updated every 10 seconds. So if the process is in running status, so remember guys one thing, the checkpoint file is updated by default every 10 seconds only if the process is in running status. If the process is abandoned, stopped, then the time since checkpoint will not update because checkpoint file will not be updated. So this value in normal circumstances will not exceed or cross 10 seconds. So when a process is stopped or abandoned, you will notice that timing continuously increases as the checkpoint. Okay. So in this example, we notice that DPINT 29 is abandoned for last 38 hours. So when the process will start, it will start from the timing where it was stopped at, ensuring no data loss, preserving data integrity. So time since checkpoint is time elapsed since the checkpoint file associated to the process was updated. Now, lag at checkpoint is the lag encountered when the checkpoint file was updated. So whatever the lag was at that time, whatever the lag was at that particular time when the checkpoint file was getting updated. It is called as lag at checkpoint. So checkpoint file gets updated every 10 seconds. When the checkpoint file was updated last, lag encountered for the process at that moment is lag at checkpoint. Okay, so this is the difference between the two, lag at checkpoint and time since